All right, so it's 6.6 for solving quadratic equations by factoring. So the one thing that's good as far as this section goes is there's really not anything new as far as factoring. You should already established everything you need to solve these problems as far as the factoring aspect. The only thing that's new is this keyword equations. When you see the word equations, that tells you you're going to have an equal sign. And when you have an equal sign and you have variables, that means you're basically solving for x. All right, so the first kind of example you're going to see, they're actually already going to be factored for you. Okay, so they didn't give you a trinomial that you had to factor to two binomials. It's already in its binomial form. And they just want to know what does x equal. And this is you're going to have to do in a lot of these problems. You're going to have to factor it. And then your last step is after you factor it is to set each factor equal to zero. Oops, it should have been x minus 6. You set each one equal to 0 and then solve for x. So again, I'll do a few of these the long way, but eventually you're gonna get the gist of what we're doing here. Getting that x by itself, you're doing the inverse operation. So you're gonna have x equals 3 and then x equals 6. I'm going to show you when we get to some more problems on how you have to enter these, but basically you're going to enter, you'll have more than one answer, and you're just going to enter them, separate them with a comma. So if it's the answer is 3 and 6, you're going to write 3, comma 6. And then some of them, this one's already factored again for you, number 2. And even when you're factoring, you may factor out an x. And when that happens, you're just going to say, well, one of the factors is x equals 0. It's already, you're going to put that x with the 0. And then you'll come to your x plus 2, set it equal to 0. And what you're going to notice is if it's a plus 2, your answer is going to be negative 2, because again, you're going to subtract 2. So you're always going to do kind of that inverse operation. So some of you, you may see that x plus 2 and just know that one of the factors is going to be x equals 0. So like here, x minus 3, x minus 6, you'll say, well, it's going to be 3 and 6. Well, it's positive, because when you do the inverse operation, so if you start skipping those steps, that's fine. Just, just be careful a little bit. Let's get into one where it's not factored. Okay, so it starts out kind of the same as what we've been doing in some of the previous sections, where you'll have to factor this first. And if you remember, when we didn't have when the a value was 1, which means there wasn't a number in front of that x squared, we just looked at that 32, and we were looking for the factors of 32 that would give me negative 12. That would add together to give me negative 12. And what we know is, since that's negative, that both of these binomials are going to be x minus x minus. Okay, and so the numbers that multiply to give me 32 and add together to give me 12 is negative 4 times a negative 8. Negative 4 times negative 8 gives me positive 32. And when I add negative 4 and negative 8 together, I get negative 12. So we already had our negative signs there, so we're just putting these values in. And like I said, at this point, you would set them each equal to 0 and solve. And as you get better at this, once you get here, you're going to know that x equals 4 and x equals 8. Okay, and let me use this time to kind of show you what you have to do on these. I think this was number 4. All right, so we already said, we established the factors are 4 and 8. Our answer is x equals 4, x equals 8. So again, when you put this answer in, you put 4, then hit a comma, and then press 8. That's it. Don't put them in brackets or parentheses or anything like that. Just 4, 8. Check answer, and you're done. All right, the next type of problem, I should have preferenced this to begin with. What you need on this right side is 0 for every single one of these before you start. So if there's a value that's not 0 here, we need to make it a 0. In other words, let's look at example or number 6. So what you see is x squared minus 3x equals 28. So I don't have 0 on this right side. So what I have to do is subtract 28 to both sides, and you're going to have x squared minus 3x minus 28 equals, and then you'll have, that's how you'll get that 0 there. Okay, so that would be your first step, is to make sure you have 0. And again, these are not like terms, that's why they don't add in to give me one thing there. That's a negative 3x, that's a negative 28. And then again, I don't have an a, so I'm just thinking of the factors of negative 28. That will give me negative 3, and it's negative 7 times 4. So we know, again, this is x minus 7, x plus 4 equals 0. So we factor the trinomial, and then we know we're going to set them each equal to 0. So this is going to be x equals 7, x equals negative 4. And I'm just kind of skipping some of these steps. These, you don't know if you don't know how I got positive 7, this will kind of explain it to you. Doing inverse operation, set it equal to 0 to your inverse operation. That one. Next one. Actually, I think number 5. All right. So again, we do have that 0 there, so we're ready to kind of factor these. What you notice, they all have x's. So first thing we want to do is factor out that x to get it into our more traditional type trinomial problem. And with that being negative there and that being positive, we know they're both going to be negative. So factors of 30, that will give me, they're both going to be negative, so they're going to add together to give me negative 13. It's going to be negative 10 times negative 3. And so this problem will actually have 3 answers, okay? So remember, when we set them each equal to 0 and solve, we already know one of the answers is 0. This answer here would be positive 10. We know this answer here would be positive 3. So when I enter my answer, I'm going to enter 0, comma 10, comma 3. And the order doesn't matter. If I put 3, 0, 10, 10, 0, 3, however you want to enter those answers in, it'll take either one. Let's see if I've already entered number 6. All right, so again, we're going to go 0, comma, 10, comma, 3. Good. Okay, let's look at 11's a little bit different. Remember what I said, we need to have 0 on, normally it's on the right side, but since I have y squared here, I'm going to actually have my 0 over on that side because I got to subtract the 20y from both sides. So it's going to look a little bit different, but as long as I have 0 on one side, that's what I need. Right? So now before I try to factor this, I need to factor out a GCF. They're both multiples of 5 and they both have a y. So I'm going to pull out a 5y, and that's going to leave me 4y, sorry, that's going to leave me 5y minus 4. I'm going to set these equal to 0. I'm going to have 5y equals 0, and then 5y minus 4 equals 0. So this is just y equals 0, 5y equals 4. I just skip the step. We're adding 4 to both sides. So on this one, we're going to get a fraction. You'll get fractions on these. Don't panic. Some of these will come out to fractions, and you just enter, you do the fraction part first, or zero first, doesn't matter, but just make sure you enter it as a fraction there. All right, just want to make sure that I'm kind of covering each example for you. Again, we've covered how to factor these before. We noticed that 3x to the third, that's going to throw you off. And then we have the x, but also 3 and 48 are both multiples of 3. So the first thing we want to do is factor out a 3x, and then it's going to turn into a more traditional type equation that we're used to. So when I factor out that 3x, this turns into x squared, this turns into negative 16. And hopefully you remember now, this is that factor of two squares. So this would turn into x plus 4, x minus 4. And like I said, you're going to have three answers on this one. 3x equals 0, so we know x is going to be 0. X plus 4, when I set it equal to 0, I subtract 4 to both sides, so I know also x is going to equal negative 4. And to solve this one, I would be adding 4 to both sides, so x would also equal positive 4. So again, make sure when you enter it, again, the order doesn't matter, but your three answers will be 0, negative 4, and positive 4. 14. This is one of the harder type problems because what you'll notice is you have two binomials already factored for you, and then you have 9 on this side. You cannot solve this. You can't just go x minus 3 and set it equal to 9 and then solve it. What we have to do is, remember, we have to get 0 on this side. So before I just subtract 9 over here, I actually have to distribute this side of the equation. So I'm going to do x times x, x times 5, negative 3 times x, and then negative 3 times 5. And after I've done that, then I can move that negative 9 over. So let's do that first. X squared plus 5x minus 3x minus 15 equals 9. Let's combine our middle terms, x squared, so this will be x squared plus 2x minus 15 equals 9. All right, so I'm just distributing this binomial. Now I need to move that 9 over. So I'm going to subtract 9 from both sides. I'm going to have x squared plus 2x. And this would give me negative 24 equals 0. Okay, so we have to distribute that out first, then move that 9 over. Now I'm looking for the factors of negative 24. That will add together to give me 2. That'd be 6 times a negative 4, because I want a positive 2. So this is a factor that x plus 6, x minus 4 equals 0. So again, our answer would be x equals negative 6 would be 1, and x equals 4. Positive 4 would be our other answer. So just be careful with that one. Just got to factor it first, move that 9 over, then you should be able to factor that trinomial there. Let's look for, we'll do a couple more examples I want to go over with you. I'm going to squeeze 15 in over here. This is one of these, kind of bigger type factors where I recommend you go to that website again. So we do have an a value and we can't factor. It'd be easy if we can factor something out of this, but there's not a number that goes into 3, 20, and 32. There's not a common number. So this is, we're doing a times c. 3 times a negative 32. We end up getting a negative 96. So usually at that point is where I just go right to my I go to that website, and I think I already had it in there from when I did it before. So I put in negative 96, calculate, and it'll give me all the factors of negative 96. And remember, for every combination, there's an opposite combination. In other words, so 9 times negative 96, I also have to do positive 96 times negative 1, so it switches around. And just be careful. Remember, we're looking for the numbers that will add and give me a negative 20. So see, 20 minus 4, that gives me positive 20. I don't want positive, I need the negative, so I have to use this combination right here. 4 times negative 24. So it's 4 times a negative 24, and that's what I'm using to rewrite the negative 20. So I'm going to have 4x minus 24x. Again, if you add those together, I get negative 20. Just rewriting those so I can use my grouping method for these. Here I'm factoring out, all I can factor out is an x, and I'm going to have 3x plus 4. Again, the key is that negative sign right there. Tells me I have to, whatever I factor out has to be negative. And the number that goes into 24 and 32 would actually be 8. And when I divide negative 8, and I'm dividing negative 8 into both of these, and I'm going to get 3x plus 4 again. Remember, these are all set equal to 0, but that doesn't really apply until I finish factoring. 3x plus 4 is 1, x minus 8 is the other. And I'll actually finish this one up the long way. Three x plus 4 equal to 0, x minus 8 equal to 0. This is a two-step algebraic equation where I subtract 4 first. And I'm going to get 3x equals negative 4. Divide 3, divide 3. So x equals negative 4 over 3. Here I'm going to add 8 to both sides. And I'm going to get x equals positive 8. So these are my two answers. Again, you would enter negative 4 over 3, put a comma, then an 8, or 8 first, negative 4 over 3. It'll accept either ones. And my last example is one of these, again, factors of two squares. I know I have it because I have a perfect square with a minus separating the two. So it's 5x plus 2, 5x minus 2. And just remember, you got to set them equal to 0 and solve. They're going to be two-step algebra equations. Work it all the way out. Subtract 2 from both sides first. 5x equals negative 2. Divide by 5, divide by 5. So the first one is going to be x equals negative 2 over 5. This one we're going to add 2 to both sides first. Move the 5x down. And divide by 5, divide by 5. So one's going to be x equals negative 2 over 5, and one's going to be x equals, oops, this would be a positive. I don't have to put that positive there, but negative 2 over 5. So again, your answer when you put it in, negative 2 over 5, comma, positive 2 over 5. All right, so that is actually the last section we had to cover for 6.6. Make sure you do your review. Shoot me an email, let me know you've done all your work. And I will send you the password for the chapter 5 and 6 test.